Good evening, everyone. So welcome to my YouTube channel, Maths of Fun. So today we are going to see a new topic that is called direct products. Okay. So we will see it. This is lecture first. So let's start today's session now. So what is external direct product? Okay. External direct product. Okay. What is external direct product? Let G1 and G2 be two groups. Okay. We write G1 partition product with G2 is equal to G1 G2 such that G1 belongs to G1, G2 belongs to G2. Okay. Let us define an operation on G1 partition product G2 as follows. G1 H1 G2 H2 G1 G2 H1 H2 is equal to G1 H1 G2 H2. Okay. We have G1 H1 belongs to G1 and G2 H2 belongs to G2. For this operation, G1 partition product G2 is a group and this group is called the external direct product of G1 by G2. Okay. So, proof. So proof of the fact that G1 plus G2 is group with respect to operation G1 in star. So what is star here? So I am calling this equation or this operation star. So I am calling this operation star. Okay. Let's prove it that this forms a group actually. Okay. Number one, closure property. Okay. Let G1, G2 belongs to G1 partition G2 and H1, H2 belongs to partition G1, G2. Okay. Since G1, G2 belongs to G1 partition G2 implies करता है G1 belongs to G1 and G2 belongs to G2 and H1, H2 belongs to G1 partition G2 implies that the H1 belongs to G1 and H2 belongs to G2. Okay. Now G1 from H1 both belongs to G1. This implies G1, H1 belongs to G1. Okay. By closure property G1. Okay. And G2, H2 belongs to G2 implies that G2, H2 belongs to G2 by closure property in G2. Okay. Next, G1, H1 belongs to G1 and G2, H2 belongs to G2. So this implies G1, H1, G2, H2 belongs to G1 partition G2. Okay. So it means G1. What is this? This is nothing but G1, G2 operation H1, H2. Okay. Therefore, closure property property is satisfied in given partition G2. Okay. Now, second one is existence of identity. Second one is existence of identity. Let E1 be identity in G1. Okay. And E2 be identity in G2. Okay. Let G1, G2 belongs to G1. Then what is this? G1, G2, E1, E2 is equal to G1, E1, G2, E2. But this is nothing but G1, G2 because E1 is identity is E1 and E2 is identity in G2, capital G2, group J1 and J2. Okay. So I can write it E1, G1, E2, G2. So again, this is E1, E2, G1, G2. So what we have? We have G1, G2, E1, E2 is equal to G1, G2, E1, E2, G1, G2. Okay. For all G1, G2 belongs to G1 partition G2. So this implies E1, E2 belongs to G1, G2 is identity element. Okay. So this implies E1, E2 is identity element. Is identity element in G1 plus G2. Okay. So you can write then E1, E2 belongs to G1, G2 because E1 belongs to capital G1 and E2 belongs to capital G2. Okay. So existence of identity is proved. So I would like to write a line therefore there is existence of identity in G1 plus G2. Okay. Now third one is existence of inverse. Let G1, G2 let G1, G2 belongs to G1 plus G2. since G1 belongs to G1, there exists since G1 belongs to G, let G1 inverse be inverse of G1 in G1. Okay, then G1 inverse is equal to E1 G1 inverse G1. Okay, and G2 belongs to capital G2, that G2 inverse B inverse of G2 in capital G2, then G2 inverse is equal to E2 G2 inverse G2. Now G1 inverse belongs to capital G1 and G2 inverse belongs to capital G2, implies कहता है G1 inverse G2 inverse belongs to G1. Okay, and what is G1 G2? G1 G2 inverse, that is nothing but G1 inverse G2 inverse. So this is nothing but E1 and this is nothing but it. Okay, but we can write same thing, G1 inverse G1 G2 inverse G2, because E1 is this one, E2 is this one. So this is G1 inverse. Okay, G1 G2. Okay, so this implies G1 G2 G1 inverse G2 is equal to E1 E2. Okay, is equal to G1 inverse G2 inverse G1 G2. So this implies G1 inverse G2 inverse is the inverse element of G1 G2 in G1 partition G2. Okay. Therefore, there is a distance of inverse in G1 cross G2. Okay. Now, fourth one is associative property. Okay. Fourth one is associative property. So let G1 G2 H1 H2 and A1 A2 belongs to P1 Cartesian table. Okay. Since G1, P2, H1, H2, and K1, K2 belongs to G1 Cartesian P2. This implies G1, H1, and K1 belongs to G1, and G2, H2, and K2 belongs to K2. This implies G1, H1, K1 is equal to G1, H1, K1 by associated property in G1. Okay. Because G1 is good by associative property in G1. Okay. And G2, H2, K2 is equal to G2, H2, K2 by associative property in G2. Okay. Now, G1, G2, H1, H2. Okay. K1, K2 is equal to. Now, what is this? How we will solve this? By definition of operation defined above in star equation. So this is G1, H1, G2, H2. Okay. So K1, K2 will remain as it is. Again, use the operation. Okay, in this what we will get? So this will be G1, H1, K1, K2, H2, K2. Okay. Now what is this? So what is this? This is we have already that this is equal to G1, H1, K1, okay, and G2, H2, K2 by this one, by this two. Okay, we have already have this information, so we can use this pair. So this is equal to G1, H1, G1, G2 is equal to H1, H2, K1, K2. Okay. So what is this? I should write properly. This is H1, K1, H2, K2. And what is this? You write this and it is, what is this? What is this? This is H1, H1, H2, A1, A2. Okay. So this implies G1, G2, H1, H2, A1, A2 is equal to G1, G2, H1, H2, A1, A2. Okay. So this is associative property. So this implies associative property holds in G1 cross G2. Okay. So closure property holding G1 cross G2, existence of identity is there, existence of inverse is there, and associative property holds. Okay. Since G1 cross G2 with operation defined with star satisfy all the properties of group. Therefore, G1 cross G2 is group with operation defined in star. Okay. So this is done. So G1 cross G2 is group. Okay. So this is called external direct product. Okay. I would like to give a remark. G1 cross G2 is abelian if and only G1 and G2 are abelian. Okay, so external direct product will be abelian if and only G1 and G2 are abelian. So how that G1 belongs to G1 and G2 belongs to G2. Then G1 so let first assume that G1 and G2 are abelian. Okay. Let G1, G2 and H1, H2 belong to G1 partition G2. Then G1, G2, H1, H2 is equal to G1, H1, G2, H2. And what is this? Because G1 is abelian. So I can write this one because G1 and G2 are abelian. So I can write like that. Okay. So what is this? H1, H2, G1, G2. Okay. So we have what we have G1, G2, H1, H2 is equal to H1, H2, G1, G2. Okay. So what is this? This implies G1 cross G2 is abelian because commutative property holding Cartesian external direct product. Okay. Now conversely assume that G1 Cartesian G2 is, it means external direct product is abelian. Okay. Let G1, G2, G1 and H1 belongs to G1 and G2, H2 belongs to G2. Then G1, H, G2 belongs and H1, H2 belongs to G1 Cartesian G2. Okay. Now G1 or G2 is abelian. So implies करता है G1, G2, H1, H2 is equal to H1, H2, G1, G2. What is this? What is this? This is G1, H1 and G2, H2. And what is this? Right hand side, H1, G1, H2, G2. Okay. So comparing, so this will be equal to this. So G1, H1 will be H1, G1. Okay. Okay. And this part will be equal to this part. So G2, H2 is equal to H2, G2. So this implies G1 is abelian. Or this implies G2 is abelian. Okay. So we are done. Okay. So today's lecture up to this. If you have any problem related to this, you can comment on my video. Like, share, comment, and subscribe my YouTube channel. Thank you very much for today's lecture. Thank you very much.